EPA's Multifamily High-Rise program offers eligible buildings 2 paths to earning the Energy Star. This webinar will explain in detail what is required in the Prescriptive Path. The webinar for the Performance Path should be viewed prior to this one, as it reviews the prerequisites that are common in both paths. During this webinar, having a printed copy of the Prescriptive Path is recommended. By the end of this webinar, you will be familiar with all the components of the Prescriptive Path. If you've already completed the webinar on the Performance Path, you'll notice that the components related to energy modeling are not components in this path. The Prescriptive Path is a non-modeling approach to earning the Energy Star. The prerequisites are the same mandatory requirements as in the Performance Path. The Prescriptive Path simply adds additional requirements in order for the building to achieve similar energy cost savings as the building selecting the Performance Path. These requirements were based on other known standards and the buildings that participated in the multifamily high-rise pilot. Testing and verification and benchmarking are required in both paths. In contrast to the Performance Path, there are no trade-offs when selecting the Prescriptive Path. Unless local code prevents you from doing so, you must meet or exceed all prerequisites and additional prescriptive requirements to earn the Energy Star. Although less flexible, the benefit is generally the cost savings from avoided energy modeling and ease of duplicating specs for multiple buildings. The prerequisites and prescriptive requirements have been grouped into the following categories: appliances, heating and cooling equipment and distribution, envelope, garages and sidewalks, ventilation and infiltration, domestic water heating, lighting, and pump motor efficiency. Some of the prescriptive requirements simply repeat ASHRAE requirements or prerequisites. Some exceed them. The following slides will show you the prerequisites, and where the prescriptive requirements exceed that criteria, they will be shown in red. Appliances. Many Energy Star qualified appliances and residential products are available today in the energy efficient criteria set by the EPA. Because the following are readily available as Energy Star qualified, it is a requirement of the program that refrigerators, dishwashers, clothes washers, ceiling fans, ceiling exhaust fans, inline exhaust fans, and vending machines are Energy Star qualified when provided in the building. There is no additional prescriptive requirement. Heating and cooling equipment. In the Performance Path webinar, you were introduced to the mandatory provisions of ASHRAE 90.1. Chapter 6 covers heating and cooling equipment. Section 4 of most ASHRAE chapters outlines the mandatory provisions determined by ASHRAE. Meeting those provisions are one of the requirements of this program, regardless of path selected. ASHRAE provides a 2-page checklist that can help you verify whether the building has met those mandatory provisions listed in Section 6.4. For projects following the Prescriptive Path, compliance with Section 6.5 is also required. An additional 2-page checklist is available to verify compliance with this section. Neither of these ASHRAE checklists are required to be submitted to the EPA, but are available to assist the design team in ensuring that these requirements are being met. The heating and cooling sizing and load calculation requirement is the same in both paths. Load sizing calculations must reflect the design. The installed capacity cannot exceed design by more than 20%, except when smaller sizes are not available. Loads must be calculated and equipment selected per latest editions of ACCA Manual J and S, ASHRAE 2009 Handbook of Fundamentals, or an equivalent procedure, and must use appropriate temperatures. As reviewed in the Performance Path webinar, indoor temperatures must be 70 degrees Fahrenheit for heating and 75 degrees Fahrenheit for cooling, and outdoor temperatures must be the 1% and 99% design temperatures. This prerequisite is the same in both Prescriptive and Performance Path. Since modeling is not allowed in this path, the Prescriptive Path establishes minimum efficiencies for many possible types of heating and cooling equipment that must be met. Table 1 of the Prescriptive Path lists the most common systems found in multifamily high-rise buildings and the minimum efficiency required of those systems to participate in this path. If your system is not listed, refer to the equipment tables in ASHRAE 189.1/2009, the standard for the design of high-performance green buildings. The next few slides will review examples of the prescriptive requirements related to heating equipment. When following the prescriptive path, No electric resistance space heating is permitted in any space in any climate zone. If the design cannot avoid electric resistance heating, then the performance path would need to be followed instead. Atmospherically vented furnaces and boilers cannot be specified in any climate zone. This is the same prerequisite as in the performance path. Although not all equipment in Table 1 will be reviewed in this webinar, the most common systems will be hot water boilers, gas or oil fired, that are less than 300,000 BTUs per hour must be 85% AFUE or better. If located in the colder climate zones of 6, 7, or 8, they must be 90% AFUE or better. Larger hot water boilers, gas or oil fired, that are greater than 300,000 BTUs per hour must be 87% efficient or better. If used with water source heat pumps, these boilers must be 89% efficient or better. In the prescriptive path, warm air furnaces in apartments that are less than 225,000 BTUs per hour in climate zones 1, 2, and 3 don't have to be Energy Star qualified, but they have to be at least 80% AFUE. Warm air furnaces in apartments in climate zones 4 and 5 have to be Energy Star qualified. If in climate zones 6, 7, or 8, they have to exceed Energy Star criteria due to their higher heating loads. If gas-fired, they need to be 95% AFUE or greater, and 90% AFUE or greater if oil-fired. Common area furnaces that are less than 225,000 BTUs per hour need to be greater than 78% AFUE, and all furnaces larger than 225,000 BTUs per hour need to be at least 80% efficient if gas-fired, and 81% efficient if oil-fired. Minimum efficiencies for packaged terminal air conditioners and packaged terminal heat pumps are determined using capacity-based equations. For example, the minimum energy efficiency rating for a PTAC is determined using this formula. If the proposed PTAC is less than 7,000 BTUs per hour, 7,000 must be used in the equation. Similarly, if the proposed PTAC is greater than 15,000 BTUs per hour, 15,000 must be used in the equation. At a capacity of 12,000, this formula yields a minimum EAR of 10.2 as a prescriptive requirement for a PTAC. Split system air-cooled heat pumps between 13,000 BTUs per hour and 65,000 BTUs per hour must be minimally Energy Star qualified in all climate zones. In climate zone 1 and 2, they must exceed Energy Star criteria with at least a SEER 15 and 8.2 heating season performance factor. Climate zones 4 through 6 have additional heating season performance factor requirements, and in climate zones 7 and 8, the Energy Star qualified heat pumps must have dual fuel backup rather than electric resistance backup. If heat pumps with electric resistance backup are chosen for the design in those two zones, the performance path would need to be selected instead of the prescriptive path in order to earn the Energy Star. Although electric resistance heating is not permitted as a primary heating source in any space in the prescriptive path, it is permitted as a backup heat source to heat pumps in climate zones 1 through 6. Due to availability, split system air conditioners smaller than 13,000 BTUs per hour do not need to be Energy Star qualified, but must meet the federal standard of SEER 13. In the prescriptive path, due to their larger cooling loads, split system air conditioners for climate zones 1 and 2 have to exceed Energy Star criteria with a SEER 16 or better. Split system air conditioners in climate zones 3, 4, and 5 have to be Energy Star qualified. Due to the smaller cooling load, split system air conditioners in climate zones 6, 7, and 8 only need to meet the federal standard of SEER 13. In all zones, all room air conditioners and mini splits must be Energy Star qualified. To wrap up the heating and cooling equipment requirements of the prescriptive path, if central cooling is provided using a cooling tower, the cooling tower fan motors must be equipped with variable frequency drives that are controlled by a temperature sensor on the condenser water supply pipe. For systems not mentioned in this webinar, please review Table 1 of the prescriptive path. Identical to the performance path, In-unit ducted forced air distribution systems must be properly designed and installed, and all flex duct shall follow SMACNA's installation standards. Also, bedrooms must be pressure balanced using any combination of transfer grills, jump ducts, dedicated returns, or properly undercut doors. These are the same prerequisites in both paths. Distribution systems, whether hydronic or forced air, have minimum insulation requirements. In the prescriptive path, heating and cooling, supply and return ductwork is increased to a minimum R8 in unconditioned space. Piping insulation remains the same as a prerequisite in the performance path. Ductwork sealing and allowed leakage amounts are also the same as a prerequisite in the performance path. Duct sealing must utilize UL 181 compliant methods and materials, and total duct leakage amounts must be tested to be less than either 6 or 8 CFM per 100 square feet of conditioned floor area, depending on the size of the apartment. The remaining prescriptive requirements related to heating and cooling distribution, controls, thermostats, outside air dampers, and hydronic design are all the same as the prerequisites in the performance path, and details can be found in the prescriptive path document. Also identical to the prerequisites in the performance path, buildings following the prescriptive path must demonstrate a continuous, unbroken air barrier, and apartments must be tested for air leakage, which cannot exceed 0.30 CFM50 per square feet of enclosure. As a reminder, the enclosure includes all surfaces: floor, ceiling, party walls, and exterior walls. Similar to the mandatory provisions of ASHRAE that applied to the heating and cooling equipment, the envelope components must comply with ASHRAE 90.1/2007, Section 5.4. A one-page checklist is provided by ASHRAE to help design teams confirm whether or not they are in compliance with these provisions, but is not required for submission to the EPA. This is the same prerequisite as in the performance path. Rather than follow the U-value requirements in ASHRAE 90.1/2007, the prescriptive path requirements are based on ASHRAE 189.1/2009, the standard for the design of high-performance green buildings. These minimum R values and maximum U values are provided in tables 2 and 3 of the prescriptive path, according to climate zone. Tables 2 and 3 list the climate-specific minimum R values and maximum U values for roofs, above-grade walls, below-grade walls, floors above unconditioned spaces, slabs on grade, slabs below grade, slabs with radiant heat, exterior doors, non-metal frame windows, and metal frame windows. For example, an attic in Climate Zone 5 would prescriptively need R49 nominally rated insulation in between roof rafters. Alternatively, you can follow the U value rather than the R value. For example, if selecting another insulation method, perhaps lower cavity insulation but additional continuous, the U value of the roof assembly cannot exceed 0.021. Although there is no energy model in the prescriptive path, U value determinations must still follow ASHRAE 90.1/2007 Appendix A. The area weighted average of the U values of the wall and floor perimeter assemblies is still acceptable for comparing to the requirements in tables 2 and 3 for the above-grade wall. Insulation that is installed must still meet resonant grade 1 criteria unless installed in conjunction with an appropriate amount of continuous insulation, in which case grade 2 would be permitted. These are the same requirements as the prerequisites in the performance path. Identical to the performance path, if your local building code requires that entranceways be designed with vestibules, the vestibules must have weather stripping hard fastened to the door or frame. And if your building utilizes through-wall air conditioners for cooling, insulated covers R7 or higher must be provided by the building for use during the heating season or when AC units are not installed. In addition to meeting the climate-specific envelope requirements from tables 2 and 3, to reduce thermal bridging, continuous exterior insulation is required for steel-framed and metal buildings. For masonry buildings with metal framing, continuous interior or continuous exterior insulation is required. This is the same requirement as in the performance path. Beyond meeting the window U value and solar heat gain coefficients from tables 2 and 3, windows must still be double or triple pane, with low-E glass or coating. In addition, total window area is limited in the prescriptive path to 30%. This means that no more than 30% of the gross exterior above-grade wall area can be glazing. Buildings with higher window-to-wall area ratios can pursue the Energy Star in the performance path. The prerequisites that apply to garages and sidewalks are the same in the prescriptive path. Garages must be properly air-sealed, and heating can only be used as a safety feature to prevent ice formation on the ground and not to prevent pipes from freezing. If the design cannot meet this requirement, the building cannot earn the Energy Star through either path. The one additional requirement in the prescriptive path is that when mechanical exhaust is required in the garage by local code, carbon monoxide sensors must be installed that control exhaust fan operation and prevent them from operating when there is no need for ventilation. Although the ventilated air does not represent a loss of conditioned air, the electricity consumed by these large exhaust fans can be greatly reduced by using these sensors. Identical to the prerequisite in the performance path, common area ventilation systems shall be designed and tested to satisfy minimum requirements of ASHRAE 62.1, 2007, and apartment ventilation systems shall be designed and tested to satisfy minimum requirements of ASHRAE 62.2, 2007. Providing dedicated outdoor air to each unit is still recommended, but not required. Kitchen exhaust must still be vented to the exterior. The additional requirement of the prescriptive path is that the measured rates cannot exceed ASHRAE by more than 50%. Overventilation consumes extra energy, which can be captured through energy modeling in the performance path, but not in the prescriptive path. In the prescriptive path, all ventilation ductwork must still be properly sealed, and central exhaust systems are still tested for leakage. However, the amount of leakage allowed in the prescriptive path is cut in half compared to the performance path. All the ventilation control requirements on this slide are only applicable to projects in the prescriptive path. Central exhaust fans 1/16 horsepower and less must be direct drive and have variable speed controllers. Central exhaust fans greater than 1/16 horsepower and less than 1 horsepower must also be direct drive with variable speed controllers, but must also have ECM motors. Central exhaust fans 1 horsepower and larger must simply have NEMA premium efficient motors. NEMA motors are not sufficient. They must be NEMA premium. These requirements not only reduce the amount of energy consumed by the exhaust fans, but can make the balancing process easier. These ventilation control requirements are also just applicable to projects in the prescriptive path. Central exhaust and inline exhaust systems serving apartments must have self-balancing dampers at each grill. These dampers prevent the stack effect from impacting the amount of ventilation exhausted from the space by automatically moderating how much air can be ventilated through the grill. Ventilation serving common laundry rooms must be installed with automatic demand control to turn off ventilation fans when no dryers are operating. This can significantly reduce energy consumption, as this reduces both electricity consumed by the ventilation fans and the thermal loss from the continual and unnecessary ventilation of this space. Domestic water heating systems in the prescriptive path must still comply with ASHRAE 90.1 2007, Section 7.4. In addition, the requirements of Section 7.5 must also be met. Similar to before, a checklist is available to help the design team confirm compliance with these sections, but is not required for submission to the EPA. Domestic water heating equipment shall be Energy Star qualified where applicable. Not all systems found in multifamily high-rise buildings are eligible for the Energy Star label, since that program tends to apply to residential equipment used in single-family homes. Where available, they should be Energy Star qualified. Minimum efficiencies are therefore established as follows. For hot water boilers, gas or oil fired, in-unit or central, the minimum efficiency allowed in the prescriptive path is 85% thermal efficiency. For in-unit tankless or storage water heaters, these equations determine the minimum efficiency. For example, a 50-gallon gas storage water heater must have an energy factor of at least 0.59. Since storage water heaters are readily available as Energy Star qualified, this minimum will generally be exceeded due to the higher criteria for Energy Star qualified water heaters. To determine minimum efficiencies for tankless systems, use 1 gallon for tank gallon capacity. The next 2 slides review prescriptive requirements that are the same as the prerequisites from the performance path. Atmospherically vented gas water heaters, tankless coils, and side-arm water heaters shall not be specified. If storage is provided, the maximum storage tank capacity shall still be specified based on occupancy. Self-contained or electronic mixing valves shall still be used to control hot water temperature for central domestic water heating systems. Mechanical tempering valves are still not permitted. The temperature of the stored hot water shall be just sufficient to deliver water to apartments within a temperature range of 120 to 125 degrees Fahrenheit. This delivery temperature is verified during inspections. The prescriptive path reduces the average flow rate allowed for laboratory faucets and showers. Laboratory faucets and aerators must now be WaterSense labeled. This still enables kitchen faucets to have slightly higher flow rates than bathroom faucets, since they remain at 2 gallons per minute, with no labeling requirement. Showers, even those with multiple shower heads, are now limited to 1.75 gallons per minute for the entire shower stall. The WaterSense labeling requirement for the actual shower head is the same as the performance path. The same requirement for low-flow toilets remains. They must be WaterSense labeled. In the prescriptive path, lighting must still comply with ASHRAE 90.1/2007, Section 9.4. Similar to before, a checklist is available to confirm compliance with these mandatory provisions. At least 80% of installed light fixtures must still be ENERGY STAR qualified, or have ENERGY STAR qualified lamps installed, and the energy-efficient lighting in each space must still be designed to meet proper light levels. A reminder, a foot candle is equivalent to 1 lumen per square foot. The Illuminating Engineering Society's foot candle recommendations for spaces commonly found in multifamily high-rise buildings have been listed for your convenience in both the prescriptive and performance path documents and is shown on this slide. Once you have the proposed lighting schedule and fixture specifications, the performance path calculator has a worksheet that will help you determine if light levels have been met. This worksheet can also be used if following the prescriptive path. The performance path calculator is an Excel-based worksheet used in the performance path and is available for download from our website. There's also a separate webinar that demonstrates how to use it. Common areas or non-apartment spaces have additional lighting requirements if following the prescriptive path. The prerequisites already require that these common spaces have either occupancy sensors that turn lighting on and off based on motion, or bi-level lighting controls that allow for low-level lighting until triggered, and that provide lighting at full capacity. If following the prescriptive path, these sensors are not required in spaces if automatic shutoff or low-level lighting would endanger the safety of the occupants. They are, however, required in spaces intended for 24-hour operation, such as corridors and stairwells. Generally, if emergency lighting is required by local code to remain on for 24 hours, this requirement can still be met by using sensors on the fixtures not designated as emergency. These common spaces are also subject to a prescriptive requirement that limits the amount of lighting installed. The total installed lighting power for the combined common spaces should not exceed ASHRAE 90.1/2010 allowances for those combined spaces. The performance path allowed an excess of up to 20% over 90.1/2007. This is not permitted in the prescriptive path. As you can see in this table, the lighting power densities, or LPDs, from ASHRAE 90.1/2010 have been listed for common spaces frequently found in multifamily high-rise buildings. This table is located in the Notes section of the Prescriptive Path document. Apartment dwelling units are not listed as a space type in ASHRAE, so lighting power density for highway lodging guest rooms was used instead. Multiplying the lighting power density by the square footage of a given space type determines the ASHRAE allowance for that space. For example, a 1,000 square foot corridor would have a lighting allowance of 660 watts. Summing the allowances for all the common area spaces gives you the combined allowance. EPA will allow any individual space to exceed their lighting allowance as long as the sum of the installed lighting power for all the common spaces combined does not exceed the combined baseline allowance and illumination requirements are still being met. This prescriptive requirement allows flexibility in selecting light fixtures while limiting overlighting of common spaces. Unlike the performance path, the prescriptive path has a maximum lighting allowance identified for apartments, which is 0.75 watts per square foot. To calculate lighting power densities in your building, you can use the lighting worksheet available in the Performance Path Calculator. Although ASHRAE requires that light fixtures be modeled with the maximum labeled wattage of the fixture, regardless of the type of lamp installed, the EPA does not. According to ASHRAE, a light fixture that has a maximum rated wattage of 100 watts must be modeled as 100 watts, even if a much lower watt lamp is installed. This is not a requirement in the multifamily high-rise program, so that buildings with energy-efficient lighting can account for savings associated with installed lamps, regardless of the fixture installed. For example, a fixture with a 13-watt screw-in CFL can be calculated as 13 watts, plus any associated ballast power, even if the fixture is rated for up to 100 watts. If ballast power is not known, see Appendix B of the prescriptive path for suggested ballast power. As mentioned previously, overall in-unit lighting power density may not exceed 0.75 watts per square foot. For example, bathrooms can have higher lighting power densities if other spaces inside the unit can compensate for it while still providing enough illumination. To calculate the overall lighting power density inside a unit, use 1.1 watts per square foot for areas inside units where lighting is not installed, such as living rooms and bedrooms that use switched outlets. Use data from light fixtures to calculate lighting power density of spaces where lighting is installed, and then take the weighted average to get the overall lighting power density. In spaces where some fixtures are installed, but occupant-provided supplemental lighting will be needed to meet foot candle requirements, the fixtures that are installed by the builder may only account for illuminating up to 2 square feet per watt installed. This floor plan is not drawn to scale, but demonstrates the calculations. The total square footage of this apartment is 950 square feet. If providing lighting in each space that will fully provide illumination for each space without the need of any supplemental lighting, no more than 712 watts may be installed if following the prescriptive path. Each room does not need to meet the 0.75 watts per square foot requirement, as long as the overall lighting power density does not exceed it. The prescriptive requirement can be used as a guideline for selecting fixtures. For example, a 50 square foot bathroom should target about 37 watts to maintain that lighting power density. If a room has a fixture installed, but is not intended to provide full illumination for the space, then supplemental lighting will need to be provided by the occupant. That supplemental lighting must be calculated as 1.1 watts per square foot. The installed lighting can only apply to 2 square feet per watt of installed lighting. So, if 100 watts of energy-efficient lighting is installed in the 300 square foot living room, it can at most illuminate 200 square feet, leaving 100 square feet to be lit by supplemental lighting provided by the occupant. The installed lighting cannot be assumed to light the entire 300 square feet. Similar to indoor lighting requirements, 80% of the exterior light fixtures must be ENERGY STAR qualified or have ENERGY STAR qualified lamps installed. Exterior lighting fixtures must include automatic switching on timers or photocell controls. Fixtures intended for 24-hour operation, required for security, or located on apartment balconies do not have to meet this requirement. These are the same requirements as in the performance path. The one additional requirement is that the total installed exterior lighting power cannot exceed ASHRAE 90.1 2010 allowances. Identical to the prerequisites in the performance path, exit signs are not included in the 80% ENERGY STAR requirement. However, they must be specified as either LED with no more than 5 watts per phase or photoluminescent. They must also conform to local building code and contain battery backup where needed. Pump motor efficiency. The program prerequisite requires that 3-phase pump motors, 1 horsepower or larger, shall meet or exceed efficiency standards for NEMA premium motors, where available. Single-phase pump motors or pump motors smaller than 1 horsepower do not need to meet this prerequisite. This requirement is the same for the prescriptive path and refers specifically to the NEMA Premium Energy Efficient Motors program. In addition, for buildings following the prescriptive path that have hydronic heating or cooling systems, Any motors 5 horsepower or larger for circulating pumps serving those hydronic systems must be specified with variable frequency drives. Metering is the final prerequisite and is the same as in the performance path. As part of their participation agreement, the developer of the building commits to benchmarking the energy use of the building for a minimum of 2 years after construction is complete. To facilitate this process, in mixed-use buildings, the commercial and retail spaces must be separately metered for all fuel sources and water. The building owner commits to collecting utility bill releases from as many occupants as possible and provides a release for any building-level meters or meters serving common areas. If obtaining tenant release forms and extrapolating the data is problematic, some local utilities may offer a service where they can aggregate the consumption data at the building level for a small fee. Alternatively, whole building utility meters can be installed for a fee that record whole building consumption. The other common requirement of both paths is verification and performance testing. The testing and verification protocols establish a consistent set of requirements for the inspection, testing, and verification of components related to buildings' energy performance. The intent of the protocols is to verify that both the construction documents and the final building include all prerequisites, prescriptive requirements, and that measures installed perform as expected. Any change in design during construction must be accounted for in the final T&D worksheet. If changes occur during construction that cause the building to not meet a prescriptive requirement, the building will not earn the Energy Star. The developer has the option at that point to switch to the performance path and develop an energy model that represents the as-built conditions. If this as-built model meets the 15% energy cost savings performance target and all prerequisites, it can still earn the Energy Star. The EPA requires that the T&V protocols be documented throughout the course of the project, beginning with plan reviews during the design stage. The testing and verification worksheets must be submitted and approved twice, once prior to construction and once after construction is complete. The photo template gets submitted once, after the construction is complete. A separate webinar is available that explains the testing and verification protocols and how to document them. We've reviewed almost all of the components of the prescriptive path. The final component is using Portfolio Manager to benchmark your building's energy use. Webinars are available on our website that will guide you through this process. As we conclude this webinar, let's review the steps to follow if selecting the prescriptive path. First, the developer needs to apply to the program and sign the partnership agreement. A registered architect or professional engineer works with the design team to ensure the design meets prerequisites and the additional prescriptive requirements. The results of plan reviews are documented using the T&V worksheets and submitted to EPA. The building is constructed according to design, and throughout construction, every component is verified and documented, and performance testing is conducted. At the end, the updated worksheets and photo template are submitted to EPA, and if all requirements have been met, the EPA will approve the building to earn the Energy Star. Finally, the developer must follow through on their commitment to benchmark the building energy use for 2 years. If you have questions about the prescriptive path, please visit our website for more information or email us at mfhr@energystar.gov.